So the considerations that are to keep in mind when we are to draw a line, as I have told earlier, the line has to look good. How it will look good? If there will be no jaggies, staircase effect. If there will be no jaggies, like we have to avoid these jaggies, these staircase effects, so that our line should appear straight and good in quality. It has to be lightning fast. How many lines need to be drawn in a typical scene? And these are the various considerations we have to taken care again and again. These are the line equations. Let us review the equations involved in drawing lines. Again, that is y equals to mx plus b, where I cannot see this portion, where m is the y2 minus y end minus y naught. This is the starting y coordinate and this is the ending y coordinate. Here this is the starting x coordinate and ending x coordinate. The difference, the rise in the y direction, y end minus y naught, and the run in the x direction upon run in the x direction, that is x end minus x naught, is defined as the slope of the line, and b is the y intercept, where this line will cut this y. If this line will be extended in this direction, where this line will intersect the y coordinate, that will be your b, value of the b, that can be calculated as y naught minus mx naught. The line equation, slope of line is defined by its start and end coordinates. The following diagram show just some examples of lines with their slopes. That this line has a slope m equals to 1. And this portion, first quadrant, has the slope lines with positive slopes only, and the second quadrant has the slopes, has the lines with negative slopes. The values are, as we will approach from the 0th value to the 90-degree angle, the value of the slope will increase, the inclination will increase, the angle of inclination will increase. Similarly, in this area, we could simply work out on the corresponding y coordinate for each x coordinate. If we know the from 2 to 7 we have to approach in the x direction, for every unit x direction, unit x coordinate, we can find the value of y coordinate with the that equation, that is y equals to mx plus b. First work out on m and b. M is 5 by, m will be 5 by 2, 5 minus 2 by 7 minus 2, right. It will be I think 3 by 5, and the b will be calculated as 4 by 5 with that equation. And now for each x value, work out the y value for each x value, matlab for 2, for 3, for 4, for 5, for 6 and for 7. We are to calculate the y values with the equation y equals to mx plus b. The value of m and b I have already calculated. The values we can see there, 2, 1 by 5, 3, 4 by 5 and so on. These are the fractional values which we get with this simple solution. This solution is no doubt very simple to calculate all the values. We are to now round off the results and turn on these pixels to draw our line. We are to round off these results. 2, 3 by 5 will be rounded off to the next integer pixel, that is 3. I cannot see this result, 3, 4 and 4. Only the integer pixels will be on. With this, if this line will be drawn a line like this, the 3 from 2 to 3, 3 to 4, 4 to 5, 5 to 5, 4 to 4 and then 4 to 5. The line will be like this, staircase jaggies. The integer pixel can be calculated with the two functions that are floor function as well as the ceiling function. That is, floor function will return you the next highest integer, and ceiling function will give you the next smallest integer. This is a quick note. Again, this is y equals to mx plus b. I am just skipping these portions as I have to cover DDA algorithm. The digital differential analyzer, this algorithm samples the line at unit intervals in one direction in one coordinate corresponding integer values nearest the line path of other coordinate. Following is thus the basic incremental scan convergent DDA algorithm for line drawing from for x equals to from x naught to x1. compute y equals to mx plus b. Then we are to draw this function to round off the value of y, whatever is the major deficiency in the above DDA algorithm is it just uses the floating point values and it has the rounding of operations, it has the multiplication operations also. So it makes the performance slow of DDA algorithm. So DDA takes an incremental approach in order to speed up the scan conversion. Simply calculate yk plus 1 based on the yk. Consider the list of points. These are the points 2, 2, the last point were 7, 5, the previous example. There are the calculated points like this. Notice that as the x coordinate goes up by 1 unit, the y coordinate simply go up by the slope of the line 3 by 5. This is the key insight in the DDA algorithm. When the slope of the line is between -1 and 1, between the first and the second quadrant के upper जो portion थे, begin at the first point in line and by incrementing the x coordinate by 1, calculate the corresponding y coordinate as follows. With this equation yk plus 1, the next y coordinate can be found as yk, the previous value, plus m. When the slope is outside these limits, -1 and 1 के जो एरिया उसके आउटसाइड लिमिट्स में है, इंक्रीमेंट द y कोऑर्डिनेट बाय 1 एंड कैलकुलेट द करस्पॉन्डिंग x कोऑर्डिनेट विद दिस इक्वेशन. Wherever needed, the values calculated may be rounded off up to the next integer with this function round next or the below integer value. These are the various examples. This is the code for the DDA algorithm in C language, that is DDA will take the input 2 coordinates x1, y1, x2, y2. This is the step and these are definitions. We will calculate the values of x2 and minus x1, whichever, and y2 minus y1, whichever will be highest, that will be taken as the steps and the increment will be taken accordingly. This is the code. DDA creates good lines, but it is too much time consuming due to the round functions and long operations on real values. This is the DDA examples. These are the values computed. You can see there 9.6, 10.2, these are the floating point values, and steps is equals to maximum of 11 minus 6, that is the, and 12 minus 9, means 11 minus 6 means x coordinates and 12 minus 9, this is the y coordinate. The maximum is x coordinate. So x increment will be 1, whichever is highest, that will be taken as the unit increment in the x direction, and we will take the unit increment in the x direction. Y increment is 0.6 calculated accordingly, and the values are computed as like this. The DDA is much faster than our previous example, that is the slope intercept equation. So in particular, there are no longer any multiplication involved. In the DDA, the multiplication operations are avoided. However, there are two still big issues that I need to consider here. Accumulation of round off errors can make the pixelated line. When we round off the values which are calculated exactly, we will round off those values. The line may drift away from what was intended. The line may be drift away above or below from what was intended to be. The rounding operations and floating operations involved are time consuming. So there is a next approach that can be used, that is the Bressenham's line algorithm. This is an accurate, efficient raster line drawing algorithm developed by the Bressenham. Scan converts the lines using only incremental integer calculations. No floating point calculations are there in this algorithm. That may be adapted to drawing of circles and other curves also. The symmetry property of lines, let's drive a more symmetry property of lines is used in this algorithm, more efficient way of drawing. Starting from the left end point of a given line, step to each successive column in x direction and plot the pixel whose scan line y value closest to the line path. I have only 5 minutes I have to cover. Suppose this is the xk at xk plus 1. At xk and yk I have already drawn pixel. At xk plus 1, the next pixel will be xk plus 1. At this xk plus 1, there are two options, that the next pixel may be yk or the yk plus 1. We don't know which one will be the next pixel. We only take the distances between the actual, I suppose the actual pixel will be y. I just taken the distances between these two pixels, yk plus 1 minus y. This will be the d upper, and y minus yk, this will be the d lower. With the calculations of these, assuming we have determined that the pixel xk yk is to be displayed, we next need to decide which pixel to plot in xk plus 1. The difference between these two separations will be like this. The choices are xk plus 1 yk or yk plus 1. D1 and D2 I have already told you. The difference can be calculated as this, and the decision parameter for the kth step in the line algorithm can be obtained by rearranging the above equation so that it involves only the integer calculations. Pk is defined as delta x into d1 minus d2. The calculation, the equation will be like this. The sign of the pk is same as the sign of d1 minus d2. The delta x parameter is a constant, so there is a c constant has a value of 2 delta y plus delta x 2b minus 1. If pixel at yk is closer to the line path, जो नीचे वाला pixel था, that is closer to the line path, then pixel yk plus 1, then pk is negative and we plot the lower pixel in such a case. If the pixel at yk plus 1 will be closer to the line path, then your pk will be positive and we will draw the upper pixel. At step k plus 1, the decision parameter can be evaluated like this. The values will be changed from k to k plus 1. The equation will be like this. Then the difference of pk plus 1 minus pk, it will be like this, and what xk plus 1 will be equal to xk, the next coordinate of xk. We note the previous coordinate plus 1 because it will be incremented in the unit direction by 1. The xk plus 1 is equals to xk plus 1. So, pk plus 1 will be like this, and where the term yk plus 1 minus yk will be either 0 or 1, and depending on the sign of the parameter, that is pk. The first parameter, starting parameter, initial parameter p naught can be calculated as with the putting the values of xk and yk and the putting value of c, that is 2 delta y plus delta x 2b minus 1. After calculating these values, the p naught will be calculated as 2 delta y minus delta x. The constants are calculated once for each time to be scan converted, so that we need not to recalculate again and again. The arithmetic involves only, we can see, the integer addition and subtraction of two constants. In the input two endpoints and store the left endpoint in the x naught y naught. Load the x naught y naught into the frame buffer, plot the first point and calculate these constants, and with the starting value, obtain the starting value of this decision parameter at each xk along the line starting at k equals to 0. If pk is less than 0, the next point will be like yk and xk plus 1, and the next decision parameter will be calculated as this. And if pk is greater than 0, the next parameter will be xk plus 1 and yk plus 1, and the next decision parameter will be calculated as this. At every step we will check the value of parameter pk, if it is positive or negative, and this step will be repeated until the delta x time, so that we will reach from the starting x coordinate to the end x coordinate. This is just an improvement upon the DD algorithm to use the integer arithmetic only. This is also applicable to the circle drawing too. As I have only this syllabus part, line drawing I have in my topic, so I have just explained only line drawing here. This is the code for C code for the Bressenham. Speed can be increased even more by detecting the cycles in decision parameter variable. Where the decision parameter value is same, we can get the direct next to coordinate values. This is the example where the distance is like this, and this is a summary about the Bressenham, and there is one effect that we get aliasing. This is the ideal rasterization line should be 1 pixel wide, that is our assumption, but choosing the best y value for each x value or vice versa, for choosing best x value for y value. Sometimes it produces the aliased raster lines like this. This is the original line we have drawn, and this is the anti-aliased. For this is aliasing effect. There is one solution that is called anti-aliasing. There are various methods: super sampling, post filtering, pre-filtering, many more. So we can use the multiple pixels for each x depending on the coverage by ideal line. Polygon aliasing is there. Aliasing effects are there, like jaggy should not be there, jaggies may be there, and unequal brightness may be there, and sometimes picket fence problem is there. All these problems come under the aliasing effect, and anti-aliasing is one of the solution to this aliasing. This is the summary points. Thank you.